Hi, good morning and welcome to next session with Apply Mathy. Today's topic is multiple and submultiple angles. Well, what are multiple angles? When they're existing as 2 times angle, 3 times the angle, 4 times the angle. So that is my multiple angle. Similarly, there is a concept of submultiple angle when it is less than 1. So it can be a by 2, it can be a by 3, a by 4, and so on. The question is, where in nature do I find a multiple or a submultiple angle? Although it's quite simple to look for, beta minus alpha when I'm looking at an object, certain elevation, and then another object, another elevation. So I can find out the difference, or even if I have to find out the sum, sum of the angles. But the question is, when I really have to talk about the multiple or submultiple angles, I'll taken you to my GeoGebra picture. So, just try to visualize it. I am trying to consider a circle. So in a circle, I know the angle which is subtended at the center is twice the angle which is subtended at the circumference by the same arc. So the arc is going to be a special one because I'm going to be able to construct a right angle triangle out of it, right? So obviously the one which is having a semicircle, and then I want to concentrate on some special type of a triangle. You can pause the video here and try to generate the formula for sine 2 theta. I'm doing some algebraic modifications over here, and I'm getting it in the form as 2 sine theta cos theta. Well, that's good, right? You can try it for cosine of 2 theta. Tan 2 theta is always, we consider it to be the division of sine and cos. So even, I have never learned for sine theta, tan theta. So the paper, when we get the paper, the question comes usually this form. When they ask you what is the measure of tan of 22.5 degrees, right? So here our idea is that we have to remember that formula. Which one we have? Tan of 2 theta as 2 times tan theta and 1 minus tan square theta. Again, so here we have to consider which particular angle I know. So might be here in this case, my theta that I have to consider is 22 degrees and 30 minutes, which we know is half of 45. So we know tan of 45 is 1. And here I'm going to, substitute as x and then solve it out as a form of a quadratic equation. So it usually becomes x square with a minus sign plus 1 is 2x. Again, you can pause the video and try it for yourself. So it actually looks like x square plus 2x minus 1 equal to 0. Apply the discriminant formula. I'm changing the color of my pen. It's not so good. So my x comes out to be, my God, it's not visible now. So it's going to be minus b, okay, plus minus under root of the square of b, and then plus 4 divided by 2. So it is minus 1 plus minus root 2. Well, that will be my tan of 22 degrees and 30 minutes, depending upon which particular quadrant I'm going to consider the angle in. It will be 1 plus root 2, or yeah, I think I missed a sign here. Yeah, minus 1 plus root 2, or minus 1 minus root 2, likewise, right? So this is the way the question comes in the paper. This is the way it is asked in the examination. Then it was a good one. Another problem which I would like to discuss with you is cos square A plus sec square A. What could be the minimum value for this expression? Well, looking carefully, if you look carefully at this question, this is not a question of trigonometry. It's a question of algebra. Basically, what the examiner is asking, he's asking, what is x plus 1 by x? This is what should be the minimum value of this? Go back to my identities. When I go back to my identities, I say it is x plus 1 by x whole square minus 2 is x square plus 1 by x square. All right. So the minimum value, it should be 2. But then, sometimes it is asked like, what about the functions which are not cos and sec? So I'll just I tried to plot it over here. So I'll just show you one by one. This is cos square plus sec square, minimum value 2. All right, so if I do it for, it's in red, right? So if I do it for cosecant and sine, cosec square and sine square, it's again 2. The graphs can look different. I mean, the shape is different, but concentrate upon the minimum value. For tan and cot, it is also 2. So that was one interesting problem I felt. It has nothing to do with trigonometry. This is the question which is, more of algebra. Well, obviously they do it by the other ways also. So it's up to you. Sometimes they do it like they say the arithmetic mean, arithmetic mean of x plus 1 by x half. It should always be greater than equal to their geometric mean, which in this case is 1. So they clearly say that x plus 1 by x has to be greater than 1. So, I mean, that is the application. Going forward, I'm leaving you with the last question. The video is becoming really long. I don't want to upload such a huge video. So here I'm mixing this trigonometry with arithmetic progression. So I'm just giving you a little hint. Maybe if you require, if you don't require, you can try to work it out on your own. So I'll leave you down with the answer. In case you have queries, in case you're not able to solve it, just type me into the comment section. You just have to solve it. So when you solve it, yeah, you can pause me. If you don't want to hear me, you can pause me. So when you solve it, you're going to get in this form, sine of x, right? So it's root 2 and 2. That's what will come out. So cos x would be 1. I'm considering positive case, right? So here basically my sine 2x would be 1 by root 2. So you have to consider, where all my sine would be positive. So you would get it as pi by 4, 3 pi by 4. So respective value for x would be 8. Right? If you want, I can just erase it well and write it neatly. I am not a very neat mathematician, but still. So you can find out what the common difference would be here. Do I still need to write it? Yes. Same way you can do it for the negative case also. If you consider it for the negative case, the common difference remains to be the same. Anyhow, thank you very much and thanks a ton for watching my video. We'll stop here. See you in the next session.